We're about to dive into a state of matter that seems like it's straight out of science fiction. Seriously, it's a world that plays by quantum rules, where electricity can flow forever and magnets just float in midair. So get ready. Welcome to the absolutely bizarre world of superconductivity.
But to get our heads around this, let's start with something we all know. You're charging your phone. Or maybe you've been scrolling for a while and you feel it. It's getting warm. Sometimes it gets pretty hot, right? Why on earth does that happen?
Well, the short answer is something called electrical resistance. Honestly, the best way to think about it is like friction. You've got these tiny little electrons trying to race through the wires inside your phone. But it's not a clear path. They're constantly bumping into stuff, all the little imperfections in the metal. Every single one of those tiny crashes creates a little bit of heat. Add them all up, and that wasted energy is exactly why your phone gets warm.
And this graph here shows the problem perfectly. That top curve, that's a normal wire, like copper. As you make it colder, yeah, its resistance goes down, which is good. But look closely, it never actually hits zero. No matter how cold you get it, there's always a little bit of that pesky friction left, just wasting energy as heat.
But what if you could get rid of that friction completely? I mean, what if there was a material that could just break that rule and achieve perfect, flawless conduction?
Well, that material actually exists. It's called a superconductor. Way back in 1911, a physicist named Kamerlingh Onnes found that if you cool certain materials down past a specific point, what he called the critical temperature, something totally wild happens. Their electrical resistance doesn't just get really, really low. It disappears completely. We're not talking close to zero. We're talking exactly zero. Okay, let's go back to that graph. See this bottom curve? This is our superconductor. For a while, it just acts like a normal metal. But then, bam! Right at that critical temperature, that TC, look what happens. It's not a slope, it's a cliff. The resistance just plunges straight down to nothing. It's a total phase transition, kind of like water suddenly freezing solid into ice, but for electricity.
Now this perfect state isn't easy to achieve. For the first superconductors they found, like niobium, this magical transition only happens at ridiculously cold temperatures. We're talking 9.25 Kelvin. That's just a handful of degrees above absolute zero, which is the coldest temperature possible in the universe.
But here's the thing. Zero resistance is only half the story. The rabbit hole goes way deeper. Superconductors have this other property that is frankly even weirder and so much cooler to see. It's the secret sauce behind something called quantum levitation.
A perfect conductor sounds like the ultimate discovery, right? But it's not even the most mind-bending thing these materials can do. No, their truly strange, almost magical behavior pops up when you bring a magnet nearby.
It's called the Meissner Effect. And what it means is that when a material becomes a superconductor, it doesn't just ignore a magnetic field, it actively kicks it out. It literally pushes every single magnetic field line out of its body, creating this bubble where the magnetic field is zero. It's a state of perfect magnetic repulsion, or perfect diamagnetism.
This diagram shows the difference so well. See the image on top? The so-called perfect conductor would just let magnetic fields get trapped inside it. But a true superconductor, the one on the bottom, forces those field lines to go around it. It's that powerful pushing force that creates an invisible, frictionless cushion, and that's what allows a magnet to just float in midair.
So, okay, we've got these two superpowers, zero electrical resistance and this perfect magnetic shield. Now, these aren't just cool physics party tricks. They're the blueprints for some world-changing technologies.
Let's just think about the possibilities. Zero resistance. That means we could build a power grid that sends electricity thousands of miles with absolutely zero energy wasted as heat. That's a global game changer. And because a current in a superconductor flows forever, you can use them to build unbelievably powerful magnets, which is exactly what we do for things like medical MRI machines. And of course, that Meissner Effect, the quantum levitation, well, that's the tech behind Maglev trains that could float above their tracks for ridiculously fast, smooth travel.
So all this is possible, but there's a catch, right? It all needs to be incredibly cold, which is really expensive and hard to do. And that is why the holy grail of modern physics is the hunt for a material that can do all of this, but at room temperature. A material like that wouldn't just be an upgrade to our tech, it would completely reboot our world. So the real question is, if we found one tomorrow, what's the first thing you think we should reinvent?